Hello everyone, welcome back to the channel. So today we're going to be looking a little bit of FinTech. We've got a chart, we've got alerts, we've got notifications. We can use a live platform here. We're just looking at a simulation. But what we're going to be doing is showing the power or what's possible with Free Pascal and Linux to develop a little proof of concept sort of system here. That can also be used in other spaces, such as my home air conditioning system. The possibilities here are endless. So we're going to look at the code, but just before we do that, let's have a little look at this little diagram here to show you the different parts of the program, so that when it comes time to look at the code, it becomes a little bit easier here. So basically, we've got a user interface. We've got a business logic and data layer, and then we've got our external sources as well. So we're using a TA chart, which is similar to the T chart you would have in Delphi. We are using a JSON feed, so we're using the iTick platform for that to get our price information. We are using the free tier, and that has a limitation of 5 requests per minute, but that's good enough for this particular program here. But it also means we need to be able to parse the information coming back. And of course, whenever you are using a cloud-based platform, whether it's for stock prices or weather information or whatever else, typically you're going to need to have an API key. So that is somewhere else in my system as well. When it comes to this business layer, I've got 3 units. One to handle the data service, that's iTick again. Another unit would be for our alert engine. Now what it's going to be using is basically the opening price and the current price, and working out whether it meets certain criteria for an alert to be triggered, and then if an alert is to be triggered, it will then do some sort of notification. While the demo was running, you may have noticed up the top right of the screen there a little notification window, saying, hey, an alert was triggered. So that's about it for that particular layer. And like I said, when it comes to this, the user interface, then we're using a chart. We've got both a line series and a constant line, and then we are also using a timer. And every period, we're going to be then going to the iTick to get some more data, and then that gets displayed on the chart, etc. So now we're going to be digging into the code. So what I might do is make this window here a little bit smaller, leave it off to the side here, and then let's go into here and let's see what we can do to make this a bit more easily so we can see both of them. Okay. I hope that you're able to see, both windows or part thereof. I'll flick between them as we need to. So, our main program here. So what we're doing is let's say it can be real time if we're looking at live data, or a simulation that uses a hysteresis-based alert engine, because we are using historical information as well, to detect a price movement and then provide some sort of alerting mechanism for that. It doesn't use any sound. As far as the notification is concerned, we're going to say that's thread safe, and so that it doesn't interfere with the main program. And also we've got scaling with the windows. So when you looked at the program running, maybe you would have noticed that the constant line may have moved down as the price went up, and also the window went to the moved as there was more data coming into the system. And as everyone loves, we're using a dark mode user interface, and we're just going to briefly mention some of the things to consider within that space as well. Now, most of the logic though, most of the logic is in the user interface. The notifications, my data service, and my alerts are perhaps a lot smaller than those, but they can also be used or moved into other spaces, as we're going to find out. This particular window here has a, like I mentioned before, a timer. We've got the chart here. This is the constant line, and then we also use a date time interval chart source, and this part here controls or helps to control the display of values on the x-axis. The real work will actually happen once we get that first bit of information, in terms of setting up our y-axis and also setting up the x-axis. So what's going to happen here is, on the timer routine, is that we're going to get our new quote, or get a quote from the iTick platform. If it's the very first time it's running, we'll get the opening price, use that to set up our x and y axis. Then what will happen then is, regardless, we're going to then get the last traded data and you plot that onto the chart, and we go into the price update. The price update routine will handle all that stuff we spoke about, prior, in relation to the charting, the alert, notification, etc. So if we move into our data service unit here, basically, when you are using like a cloud platform, regardless of whether it's going to be a weather service, Google, in this case here iTick, there are many platforms that you would utilize. What I'm about to describe, you need to have let's say a login. From a login you'll get a token, and that token would then typically get used in all your requests to identify you as a valid user. iTick, just as another aside, even though I'm based in Australia, I can look at Great Britain, Singapore, Germany, US, etc. So there are a variety of regions that it works well. There's many other ones as well. And what happens then is, this response that we get back gets converted into a JSON object. Because it is a proof of concept, I'm not interested, put a little question mark behind there, in whether or not I should convert this into let's say a record or a class result that just stores the opening price, the high, low, etc. But in the context of a real system, that is definitely what would be done. So every time that we will get a new price, it's going to use check the current price against certain criteria to determine whether or not an alert should be raised. It has a little tiny bit of hysteresis, we'll say, because we are going to be using the opening price, but you could modify that to incorporate other historical aspects of the data previously loaded. But here what we're going to basically be doing is to check whether our current price is above a certain percentage of the opening price. But then we also have a reset percentage, so that if the new value sort of like just jitters around that trigger line, you're not going to be in a constant push going on and off, on and off, on and off. And that can be important, especially when you were, in the case of a stock market, buy and sell signals potentially. But if you are looking at, let's say, something like your home air conditioning system, you don't, or even considering turning a light on and off, you don't want to be at that switch going on and off, on and off, on and off, and making a mess of your air conditioning system. This one here also uses a state machine, and that state machine is needed to determine when the alarm goes on and actually when the alarm goes off. And then likely we have our anchor price, which is what we use to represent our open. So now when we look at the state machine here, it starts in idle. And then once here basically we'll check how far is our current price from that opening price. And if our percentage were greater than that trigger value, then we go into an alerted state. So bang, our alarm has gone off. And we then transition into an alerted state. But now that it's gone off, we don't want every new price value to to basically refire the alarm. Again, we also don't want to do that jittery action. So what we have is our reset value, so that once it goes through that reset value, we can then go back into an idle state to then say, hey, we can raise it again. So by way of example here, if we have, let's say, 1% and 2% values on our, to use as our reset and trigger values respectively, then if it goes up to 2%, it will fire, down to 0.9%, turns off, back up to 2, goes on again. So once we know, if we now have a situation where our alert is triggered, we want to, have some sort of notification happening. And that gets handled by this particular notification service here. So here in our notification service is where is our units, our classes, etc. that we can use to manage our notification, which you saw on the top right there. It's also thread safe in respect to that this will be done in the background, because we don't want the execution of the program to interfere with the everything else in the foreground, if you want to put it in those terms, or getting new data, checking the alert, etc. So basically, to use notify send, what we're going to be doing here is to say we're going to use notify send. We tell it what icon to use, and we will have it display for 2 seconds. So that after 2 seconds, it will fade away. And that, by the way, gets handled through this code there is the execute method of a thread, which will terminate once it's been executed. Now the user, or the in terms of whoever's going to be using this unit from the main routine, it just needs to know to call notification service send, and it will basically handle the creation of the background thread. It executes, it terminates, it frees itself. So by separating the notification service from the alert, from the data service, it means each part can be easily tested independently of each other, creating building blocks that can be used further up the chain. It also means for something like this particular unit here is a non-blocking notification system. The event gets signaled and it gets cleared after 2 seconds. And in a real-time environment, this execution should not affect the UI, the collection of data, and vice versa. This code here could move from, let's say, a text, a financial text base into your home climate control by utilizing this alert engine. Rather than monitoring prices, it could monitor temperature. It may not be monitoring the movement as a percentage, but the transition, say, from idle into alerted, you could use that to turn on your air conditioner. Or when it goes below a certain value, you could then turn the air conditioner off. Also, by implementing having a trigger value and a reset value also means that you're not going to be in that on and off. It's the same logic that's being applied, but it's just being used in a different space here. This little proof of concept here, we bring up the program again just to show you what it looks like. So this little proof of concept demonstrates that Modern Pascal, Delphi, Free Pascal, the little tiny powerhouse of for an event-driven system, with features like being able to have alerts, having a state diagram to trigger alerts and have show notifications. Fast, it's safe, and can be used across a variety of industries with very few changes. If you'd like to view the code again or see the logic behind the triggers, let me know. And until next time, I'll see you on the other side, and happy coding. Bye.